I've shown it's a relative minimum, right? So now what do I have to do to show that it's the minimum of all things? I've got to keep in mind all these, right? Now, are there any other turning points? No. Are there any discontinuities? No. Are there endpoints?
Yes.
Well, yeah. Because X and Y are positive.
Now, this is tricky, right? Remember I asked you to note this down, okay? We actually didn't note down everything because positive integers, right? And they add up to 8, okay? So positive implies, okay, there's a certain bar, it can't go any smaller than that, but there's also a bar that it can't go bigger than that, right? If they're both positive integers. What's the biggest one of the numbers could possibly be? 8, right? Though sort of not really, right? Because if it's a positive integer, right, if one of them's 8, the other one will be 0, which is not a positive integer, is it?
Positive 0.
0 is neither positive nor negative. So what I should really say here, and this might be a better way to put it, a more descriptive way, is that for x, I have this domain, right? Note that it's not inclusive. It can't be at 0, and it can't be at 8 either, because being at 8 makes the other one 0. Same domain for y. Okay, are you happy with that? Now here's the tricky thing.
Then it can't be half.
These, right, you see how you never actually get to the end, right? You never get to 0. And any small value you pick, like 0.1 or 0.01, you can, well, yeah, okay, that's true. I can't actually go any further, right? So my real endpoints are actually 1 and 7, right? So even better than this, because they're integers, I could say this. Sorry, 7.
All right.
Okay. Be careful. Now, do you see how much thought goes into? It's such a simple setup, right? You gotta be careful. All right. Now, I'm gonna test my endpoints. I have to test my endpoints, right? So I'm gonna test. I actually don't need to test both of them because I have n just as a function of one of them. Okay. So I'll test y equals 1. I'll test y equals 7. Right. So here's what I've got. I'm actually going to put together a little table for myself, okay? Much like when I test derivative on either side. I'm going to have y and my value for n. Okay? So what are my endpoints? 1 and 7. Okay? What values am I going to get? Let's see. Where's my function? Here it is. So if I put in 1, I'm going to get 2 minus 16, so it's minus 14, plus 64, so that's 50. If I put in 7, it should actually be 50 as well. 2 times 49 is 98. Minus 16 times 2, that's 32. So 98 minus 32.
Would be 7.
Sorry. Oh, right, of course. What's 7 by 16?
7 times 16 is 6
100
times
and
16 plus 6.
112? 112? I should really write this down, shouldn't I? 98 minus 112 plus 64. Okay, what we expected. So I can now verify that my endpoints are no better than, well, I really should have stuck this in the middle. Okay, so now you can see this table, all it does is it helps me to compare. Okay, that's all it's doing.
So is that still necessary if you use the sign table for first derivative? Since we're testing on either side already.
Yeah, it is. I've still got to go for endpoints. Still got to go for endpoints.
What-
Because
what
in this case,
What if you tested with endpoints?
say it again.
What if you tested with endpoints?
That's complete.
Tested what with endpoints? You mean the
The first derivative.
now I would caution against that. They actually mentioned this very quickly in the exam. Maybe you missed this. When you're testing the first derivative on either side, okay. Number one, you won't get a value for n. You'll get a value for dn on dy. There's the first problem. Secondly, if you test the endpoints, you're so far away from the stationary point that other stuff could happen in between, right? So it's not a valid. You'd have to go closer, like 3 and 5, or even 3.9 and 4.1 is better. Okay.
Because of its shape,
Mm-hmm.
there's no actual possibility of the endpoints being lower.
Right. Okay. Well, also because of a better way to say than shape is the fact that there's just one stationary point.
Yeah.
And it's concave up, okay? Now again, I'm trying to illustrate the way you go through the question with a simple example. Like you could have solved this in year 8. 8 is when you did quadratics and maximum and minimum values. For those, you just find the vertex. But those methods won't work when you've got a more complicated function. Okay, so I'm doing the whole thing with a simple
If it was just
question.
this question, would we still need to do that table?
If it was just this question, which is actually a pretty typical question, and it appeared in a year 11 exam, they'd very likely say proved by calculus.
Wait, it doesn't say.
If they don't say that, though, we don't need that. Okay.
Though still,
It's okay.
for 3 or 4 marks, I think you're pushing it, right? Especially if it's 4. They're looking to apply marks to all of these little bits, right? So you probably get a maximum of 2 if you just said, here's the number, and because it's a quadratic. Okay.
Yeah,
But
but we
wouldn't that be
proved
right,
that it's the
technically?
minimum because of the axis of symmetry.
Yeah, but they're clearly, number one, it's clearly implying that they want you to show it in a more rigorous way. Number two, you're in year 11, they want you to show that you understand calculus. That's what they're testing, right?
What if they have other calculus questions?
There will probably be lots of calculus questions, and this will still be tested by calculus. Why not?
Because we don't
So
Do it!
Transition.
You wasted 5.
But why?
You need to be in front of the lens gun, but anyway. I'm almost there. We need to put our conclusion together.
Are you
It's just
slow?
a case.
Slow and red.
It's just a case.
Okay.
Oh, I got a new mic. That's the
You are so unobservant.
Notice
that.
Captain Obvious saves the day. All right.
Notice that.
Let's finish, okay? So, now that I've got my stationary point, I've shown its value, I can say, since... Now, do you remember? There's this big long paragraph here. How does it start?
I don't have a clear specific.
Oh wait.
I'm going to say, you can do this in either. This is the only stationary point.
If a function is continuous.
Good, good. Which it is.
Oh.
Do we actually have to prove
Continuity? No.
Continuity.
Continuity. Continuousity. That's good. Since this is the only stationary point and the function is continuous, don't forget the domain. Okay. The relative minimum, and this is getting at your question, Richard, is also the absolute minimum. Yeah. Minimum.
It has to. If it's differentiable, it has to be
Not
continuous.
continuous, twice.
So if it's differentiable, it has to be continuous, right?
Differentiable means the derivative is continuous. If the derivative is continuous, that means the function is continuous.
But if it's
Also,
continuous, it's not necessarily differentiable.
Correct. Because piecewise functions, right, like the absolute value of x, it's continuous, there are no holes in it, but at that point at the origin, you can't differentiate it. Because when you take the limit from both sides, you get totally different values. Da, 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 da. Now, what is the smallest possible value for n? Therefore, they ask you the question in a sentence, so you should answer in a sentence. Smallest possible value for n. Okay, Preston. Okay. Now, admittedly, that felt like a long time,
That was a long
probably
one.
because we kind of got caught up in some of the minor details, but that's what you're expected to produce. Okay. And again, I'm doing it for a simple quadratic question, so when you get, like, say, a cubic or some other weird kind of variety question, you'll know what to do. Okay.
And how do you know it's continuous?
Okay, because I actually just rubbed it off. So n equals, right, and you've got that function there, and you don't need to prove its continuity. Don't need to prove it. You can just say it is continuous. What we're looking for is the fact that you recognize that this is important, right? Because you will get sometimes discontinuous functions, and you have to account for that. So it gives you more endpoints, basically. Yeah.
You know, last time we learned about continuity, the other thing.
Yeah.
You said it wasn't necessary to learn how to like you said it was non-accessible.
That's right.
Like, is that always the case?
Let me think.
Like even like later.
Yes. Yeah, all the way up to the HSC. The reason why it's in the program is because you need to understand, actually, it's because of this. It's because of this topic. Because continuity has implications for whether something's a max or it's a min or etc. You don't need to prove it. You just need to know what it is and how it affects your answer.